Hey everyone. Today I'm continuing in my series on exploring new AI tools that can change your developer and engineering workflow. Today I'm really excited to be checking out Julius AI. It's something I've wanted to play with for a while now and have finally gotten around to it. The gist of the Julius AI pitch is whenever you are engaging in some sort of data science, data analysis task, you have to go and look at your data, extract some insights, do exploratory data analysis, really just get to the point of understanding what this data is even about. And Julius is using LLMs under the hood to power and expedite that data analysis process. And so for this really quick video, what I want to go through is just test its capabilities a little bit and walk through some of the things I want to see it do, see how quickly it can do this, and then ultimately give you guys something to go off and try on your own. So for the purposes of this video, I'm going to be checking out a data set that is probably well known to a lot of people, which is the movies data set. It's been around a while. It's just a collection of ratings on some 45,000 movies across the world, some 26 million ratings, 270,000 users, and it's an interesting data set. It's a classic one. It has both numerical information as well as textual information, and so it just gives you that little bit of that multimodal flavor that might be interesting to check out. And we're going to be ingesting it and seeing what kind of things Julius can derive. The first thing I'm going to do is upload the data set, or at least some parts of the data set. Julius is neat because all you have to do is you can provide a CSV, and it's pretty good at ingesting that. You can also provide other data formats like Excel files and things of that nature. For the purposes of this particular demo, I'm going to walk through one of the files in the movies dataset. In this case, it is the movies metadata part of it. I'm going to pull that into Julius, and here Julius is ingesting it. Now, for context, the movies metadata file, this is roughly what it looks like. So it has a bunch of different columns about metadata related to the films, everything from budget, genre information, IMDb IDs, titles, overviews of the film, kind of which production company was responsible for it, and other types of things like that, release date, revenue, a lot of things that you might want to analyze when you're trying to understand something about movies. And so there's a lot to work with here. As you can see, Julius is pretty good at ingesting it pretty quickly, and that's what it's done here. So once it's in, we can actually just start playing with it. And I think what's one thing that we'll call out here is Julius is pretty strict about having data that's provided be of a certain form, like not having empty rows, not having composite tables, which is something when you're getting involved with really complicated Excel sheets. You can sometimes have really weirdly formatted things, especially when you're looking at financial data, just like rows and skipped rows and skipped row headers and skipped column headers, and it's just a mess. And so in order for Julius to work, you actually do have to make it pretty much a dense row by column format, which for most typical public benchmarks, they usually do that tough work for you. So why don't we go and do some just like basic analysis? So there's budget information. Maybe we can do a quick tell me, or maybe give me a histogram of the budget info, because we want to see roughly what's the distribution of budgets across the films. So we're going to have it take a look at that, and what you can see is Julius is kind of walking us through its process. Under the hood, it's certainly powered by LLMs, and it's generating a lot of code, in this case typically pandas code, matplotlib code, seaborn code for visualization, and it's doing that. And sometimes what you'll see is as it generates its first bit of code, it might run into errors, and when it does that, it'll actually try and correct itself, and I think it has some mechanism for maybe feeding in those errors back in to actually try and understand, to actually try and correct those errors, and then eventually it'll get to something that's pretty decent. So here, boom, there you go. There you have it looks like it's matplotlib generated, matplotlib generated graph, the histogram of the budgets, and even gives you a little short summary about that histogram information. About close to 9,000 films with non-zero budgets, average budget amount, median budget amount. Obviously, it's a very skewed distribution. Most films tend not to have very large budgets, even though we are skewed into thinking that a lot of films have like $100 million plus budgets. Those are really the Hollywood heavy hitters. Most do not. But that's cool. So, it did it really quickly. And one thing that I already like is I never enjoy and never have enjoyed having to wrangle matplotlib commands. Just never can commit that to memory. And so the fact that it's able to do that in an automated fashion is great. So already +1 there. And we have like a reasonable looking result. Now we might go back and say, well, is there other stuff that's worth analyzing here? And if we go back to what's the format of this data, we can see, among other things, a lot of information around production companies. And maybe what we can do is, and what's interesting about this particular column is the production companies' values are actually, looks like JSON objects. And so it's not as trivial to just pull the column, feed it into a single map pandas command. It actually has to do a little bit of unpacking of the JSON and maybe interpreting some of the field values, which is where LLMs would be helpful here. But maybe we can do we can ask a quick question, like what are the top 5 production companies in terms of movies made, and how many movies have they made? Natural language request, or a question that we're asking the system. We'll see what it comes up with. Again, generating Python code under the hood. In this case, it doesn't really have to interact with any visualization software. And what we can see is it's great. It's pulled out Warner Bros., MGM, Paramount, 20th Century. Sanity check looks good. This is one thing that's a little bit, you kind of have to take a little bit of a leap of faith here, because without going and doing the analysis to verify the results, you just have to trust the results. Otherwise, if you were going to do the analysis, why would you be using this tool in the first place? But it altogether looks pretty reasonable. So that looks good. What else might we want to discover here? So one thing that's kind of interesting is, we might ask, like, what is the, maybe we can compare, there's different genres for films. Can we compare the budgets of those films in a certain genre? So what's the difference in maybe romance genre films versus dramas or thrillers? And so here we're going to try ask a little bit of a composite query and see how it deals with that. So maybe what's the distribution of budgets for drama films versus horror films? Maybe there might be some difference. I suspect drama films tend to be a little bit lower on the budget side. Horrors I don't think are super crazy either. But maybe actually, for the purpose of the demo, let's pick something that's a little more stark. Maybe like action. Action films tend to be pretty heavy on the budget side. A lot of effects that they have to deal with, CGI, things of that nature. So we really should see a pretty stark difference in those two. I mean, that was quick. Look at that. 50 lines of Python code. Nice and good. Looks pretty reasonable here. And even give us a little plot here. A little box plot of distributions, drama films. Mean budget about 16.8 million median. I guess median doesn't really show you here. I guess maybe missing the number. Yeah, so I guess maybe this formatting was a little bit off. But in general, as we would expect, action films tend to be higher on the budget side. We can see that there's release date. So maybe one thing we want to plot is what's the change in budget over time. So here we have both temporal plus numerical analysis. So we want to see, do films get more expensive over time? I mean, hypothesis is yes. Let's get this verified. Can you give me, so let's get this verified. Can you give me a plot of the budget, the average budget for film over time based on release date? This is cool. Nice little looking plot here. Looks like for a large period of time, actually, budgets were pretty flat, except maybe a little spike here. Looks in the kind of the maybe late 20s. I guess there's just like a prosperous era for American culture. I guess like the world in general. Before the crash, I guess, of the Great Depression and the financial crisis of the world. And then it looks around 1970, it really just started picking up. People, I guess, maybe movies just became more mainstream. And the other thing that's kind of interesting here is the dip from the early 2000s around the dot-com boom and bust, how it just dropped very aggressively around, well, the 2008, 2009 era. What happened then, I guess, again, crises. And so, generally, crisis leads to the pinching of budgets, not just in terms of consumers. I mean, certainly in terms of consumers spending, probably as a consequence for production companies' budgets to make films, because if consumers maybe aren't spending as much money buying things, then there's less money to be made from consumers, and so the budgets themselves for films will become more conservative. And then once we got out of that rut, again, boom, just a big spike. So this is super cool. Maybe I'll ask one more thing. Just to push the limits. Can you make a t-SNE plot for the word embeddings of the taglines? I mean, this is like pretty, there's a few libraries that have to be plugged in here to have to do some embedding. I would be incredibly impressed if this worked, because again, it's multiple steps. It's not just vanilla Python like pandas and matplotlib code. You actually have to probably import a few libraries. All right, so ultimately it got stuck, didn't figure out what it could do, tried to install and uninstall and reinstall a bunch of libraries, and just never really completed the task. As I said, it was a little bit of a stretch. I would have been pretty impressed if it was able to pull that off, given how many moving pieces there are. Some pretty involved libraries, definitely would have been heavy on compute and storage. And again, depending on the workflows they're supporting under the hood, they're trying to be a horizontal data analysis tool. So as you get deeper into a particular way of interacting with the data that you particularly care about, this might not be as relevant. That's okay. I think that for generic data analysis tasks as a horizontal platform, this does a pretty good job and saves a decent amount of time. I mean, as I said, I always hate having to deal with matplotlib and things like that. So the fact that it's able to generate basic visualizations using those libraries without me having to do anything, that's a pretty solid win. The lines of code is not a huge number. A lot of the scripts are 50, 60 lines of code from what I've seen. It's not a tremendous time saver, but it is a pretty good one. And I'm not sure how this would fare in like more complex, involved data sets, where honestly most of the hard work of data analysis is the pre-data analysis, so to speak, which is the data wrangling, getting the data in the right format, cleaning it up, making sure that it's properly, kind of in the format that is actually acceptable for processing. Here, Julius sort of presupposes that you've already done the work of putting it into a structured, dense representation. Pretty big of an assumption, I think, as I said, for a lot of financial data, profit and loss statements, just company analysis, I mean, anything really. It's not going to come in a nice format, especially a lot of these things come from Excel, and you can just brutally massacre the format of data in Excel, and so, or Google Sheets. So it'll probably, Julius would struggle a little bit more in those situations. But overall, I think that for the hobbyist, I could see myself using this. For people that don't have very, very tailored data needs, I think this is a pretty nice thing to use. One analysis we haven't done is just how does this compare to like feeding in the CSV into a GPT-4, a Claude, and then just running the exact same commands. What difference would it make? I suspect that under the hood they probably maybe offer a bit more support on the visualization libraries that are installed out of the box. but at the same time, and they probably do some like clever prompting in certain situations, or rewriting of prompts. But overall, pretty neat tool, neat workflow. Check it out if you get a chance. It's a neat time saver when it comes to data analysis. That's all for now. Thanks for listening.